Hi everyone, and welcome to Algebra Revision. Now your test for this is on Tuesday next week, which is in week 5. The questions that I've prepared for you to have a look at as part of your revision are mainly the C-level questions, or the questions that you'll need to pass, basically. The upper end of the test, maybe the top 30% or so, is made up of the A and B level questions. Now these are more similar to the understanding, reasoning and problem solving questions that we've done in class, so if you're aiming for those sorts of grades, it would be good to revisit some of those as well. Now, as you can see on the screen just here, we have a very serious looking T-Rex informing you that it's ultimate revision. Nice work, Mr. T-Rex. And here's a few bits of information that, well, I've basically just said that, so I'll just get straight into it instead. Okay, the first set of questions is to do with writing algebraic expressions. We can represent many things using algebra, but these are some of the simpler ones that you'll have to do right at the beginning of the test, more than likely. Now remember that when we're going to represent these items using, or these expressions using algebra, we're going to take the sentiment which talks about a number, and just instead of saying a number, we're going to represent that with a letter. So say your name is Melvin, for example, you might wish for your letter for a number to be the letter M, and that's totally fine. So say if you wanted to say, well, what's an expression for a number plus 4? You can choose the letter M as your, I was going to put the grid lines on, make it a bit neater. You can choose the letter M for your a number. Hang on one moment. There we go. So M is what we're going to use to represent a number. So the expression a number plus 4 will be M plus 4. Now M stands in for any number ever. Like what M actually is and what it represents doesn't matter in algebra, at least not for this question. Same for the next one, a number minus 9. We can still go M maybe for milliliter this time, so M minus 9. Double a number. Let's say our number is B for Brie. Well, if we double it, we're going to multiply it by 2. So you might be tempted to write 2 times B. But remember in algebra, when we're multiplying a number by a letter or a coefficient by a variable, we don't bother writing the multiplication symbol. It's fine just to write 2b for that one, because that means the same thing, 2 multiplied by b. Next one, a number divided by 11. Let's go F for Flynn, divided by 11. And again, in algebra, you can express that as a fraction instead, in which case you'd write F over 11. They mean the same thing. Either of those is fine. The sum of B and A is just B and A added together. So whatever B represents is added to whatever A represents. That's fine. And just a bit of, I've chucked this in just to remind you of a bit of the language. When it says the product of B and A, when you find the product of something, it means to multiply them. Like the product of 6 and 3 would be 18, for example, because 6 multiplied by 3 is 18. So the product of B and A will be B multiplied by A, or, like I've said before, as we just write in algebra, BA is fine. Cool, it's pretty straightforward, hopefully. These ones are slightly harder. These are taken from Maths Quest. So the amount of money earned by selling B cakes where each cake is sold for $4. So let's say for this one, well, it's actually already given us what it wants us to call our variable here. We're going to represent the number of cakes that are sold with B. So B is definitely going to be in there. Now, the amount of money earned, well, if each of those B cakes is $4 each, the amount of money that you're going to take in is whatever B is, so the amount of cakes that you sell multiplied by 4. So then if you sold 4 cakes, you would have made 4 times $4, which is 16. If you sold 10 cakes, you'd make 10 times $4, which would be 40. A bit weird that it took me a second there to work that out. That means I need to have a synth arpeggio break. Okay, now my concentration has returned. I'll also change that to a B and this one to a C. Okay, the total number of sweets, if there are bags of sweets with 45 sweets in each bag, very similar situation here. You're going to have the number of sweets in a bag, which is 45, times by the number of bags. So if you've got 2 bags of sweets with 45 in each, you'll have 90 sweets in total, because that would be 45 sweets per bag times 2 bags, which would give you 90 in total. Cool. Now on that note, the next one is substitution. Now in substitution, we're given an algebraic expression, but we're actually also told what the variable is standing in for as well. So for all of these questions here, x is always equal to 4 and y is always equal to 9. So first one, we've got the expression 3x, but we're told in this case that x is equal to 4. So for this one, we'll swap x for a 4. So 3 multiplied by x becomes 3 multiplied by 4, which is 12. Easy. Similarly for the second one, 2y, because we're told what y is, it's 9 in this case. It's a substitution question. So 2 multiplied by y becomes 2 multiplied by 9, which is 18. Awesome. Next one, well, we've been told that x is equal to 4 in this case. So we'll swap x for a 4. 4 add 5 is 9. Nice and easy. Couple of harder ones. Next one is, 3x plus 5 equals 3 multiplied. We've been told that x is 4 this time, so 3 multiplied by 4 plus 5. 3 multiplied by 4 is 12. 12 add 5 is 17. Cool. This one combines both of them, so it's 4x take y. So I'll write that down real quick. 4x take y becomes 4 multiplied, swap x for 4, and then take away, swap y for 9. That becomes 4 times 4, which is 16. Take 9, which is 7. Last one, 2y plus 10. So 2y plus 10 is equal to 2 times 9 plus 10, which is equal to 18 plus 10, which is equal to 28. Now, a couple of you got confused when we first started learning this. A couple of you said something like, oh, remember yesterday when x was equal to 4, does that mean that x is always equal to 4? Well, no, because x normally stands in for any number. It just means in this question specifically, we know that x is equal to 4 and y is equal to 9, when really they stand in for any number. It's kind of like these expressions that we just did where the amount of sweets we have in total, if there's G sweets in the bag with 45 in each bag, we might happen to know this time that we've got 6 bags of sweets, so we'd have 6 lots of 45 in total. All right, what's next? I'm simplifying expressions. I'm just going to write a little bit out to the side to start with. Remember that 3a is just saying 3 multiplied by a. It means you've got 3 lots of a. If you're going to add 2a onto that, you've got another 2a's. So adding those together gives you 1, 2, 3, 4, 5 lots of a. So your answer for that is 5a. Key to that is whatever your variable is, as long as it's the same type of thing. So in this case, you've got 3 lots of a. This one, you've got 2 lots of a as well. You can add them together like normal numbers. So first one just there, 3a plus 2a, like we've just said, is 5a. We'll do b as well. 9y plus 5y. Well, 9 lots of y plus 5 lots of y is going to be 14 lots of y in total. Kind of like if you had... we'll do this next one as well. So 4 lots of u, take away 2 lots of u. So if you've got 4 lots of, that's not a u, 4 lots of u up here, and then you take 2 of them away, you're left over with 2 u's. So 2 times u. And then last one, e, 7e plus 13e. Same sort of thing, 7 lots of e plus 13 lots of e equals 20 lots of e. Remember that some of the harder ones that we had to do in class went a little bit like this. We'd have to check out ones that had 2 different sorts of variables in there. So say, for example, 2x plus 3b plus, let's say, 2x again. So if you write those out like the long way, just to help me or help you get an idea of it. So 2 lots of x, you've got 2 x's, it's 2 times x. 3 lots of b, you've got 3 b's. 2 lots of x, you've got 2 x's. If you add all of those together, you've got 4 x's in total. So 4x, and then 3 b's as well. So 4x and 3b. And that's an example of only being able to add together I suppose, parts of the expression they're adding the same type of variable. So you can add these together because that's 2 of x and that's 2 of x as well. It's 2 of the same sort of thing, but you can't just smash them in together and say, oh, that's 7bx, because it'd be like saying I've got 3 apples and 2 oranges, or no, I've got 5 apple oranges. It doesn't work that way. Okay, cool. Scrolling down. This one I'm just going to press pause and set myself up a quick table. Okay, hey, welcome back. Now these are both number patterns questions, and you've got to work out what the relationship is between the number of shapes and the amount of matchsticks required to build them. Now, like we said in class, you've probably seen these number patterns questions before, but coming up with an algebra style rule is something that is probably new to a lot of you. Anyway, so first shape just here. And that's shape number 1, there's one triangle there, and it's made up of 3 matchsticks. Shape number 2 is made up of 5 matchsticks, and shape number 3 is made up of 7. Now the trick to this is to see how many matchsticks are added on for every time you add a shape on. So when you go from 1 triangle to 2, we add on 2 matches. And when we go from 2 to 3, you add on another 2 matches. Now what that tells me is that for every shape that we add on, we're going to need 2 more matchsticks. So if we were going to make a formula or a rule for number of matchsticks that were required, if we know that we need 2 matches for each extra shape, it's going to be something to do with 2 multiplied by the number of shapes. Now what you'll need to also do is add or subtract something to make it work. So let's say we take the first shape, we're going to multiply it, the shape number, which is 1 by 2, which gives us 2. Now we still need to add on 1 to make that rule work. So 2s plus 1 seems to work for the first one. Let's check out the next one. Now 2s plus 1, so 2 times 4 plus 1 is 5, that works. 2 times 3 plus 1 is 7. So that's fine. So we know that our rule is correct. Now the next thing you're asked to do is work out use your rule to work out how many matchsticks you're required to use for 20 shapes. Then it just becomes a simple substitution question. Let's do that real quick. All right, so our formula is m equals, or number of matches is 2 times the number of shapes plus 1, or 2 times 20, because it's how many matches for 20 shapes, plus 1. 2 times 20 is 40, and 40 plus 1 is 41. Awesome. Now I'll do the same again quickly for these second shapes, these house things. So when you've got one house thing, you've got 6 matchsticks is what's required. When you've got 2 house thingies, you need 11, and when you've got 3 house thingies, you need 16. Similar thing again, we seem to be adding on 5 each time. So our rule is going to be something to do with the number of matches required is something to do with number of shapes multiplied by 5. Now work out what you need to add or subtract to make the formula work. So 1 times 5 is 5, and you need to add 1 to get up to 6. Let's try it for the next one. 2 times 2 is 10, add 1 is 11, that works. 3 times 5, or 5 times 3 is 15, add 1 is 16. Cool, formula works, that's great. Now the number of matches that we need for 20 shapes is as follows. So 5 times 20 plus 1, which is 100, plus 1, which is 101. Not Dalmatians though, we need 101 matchsticks. It's the wrong topic for that. Okay, now I've included on here as well one of the problem solving questions, and the reason that I've done that is to show you the sort of thing you'll need to do for an A or a B level question. Because the idea with these is that you've not seen a question exactly like this before, but you've got to apply what you've learned and use what you what you understand from the topic so far to get to a solution. But before I even start this, if I was doing the test or doing this question, I would look at it and go, well, I'm doing an algebra test. It's probably something to do with number patterns because I've got something growing by a certain amount each time. Let's see if there's a pattern to it. Now, between the first measurement, and by the way, it looks like a plant has been put into a pot, and they've measured how much it grows from the very first measurement and then with every subsequent day after that. Now, to get from the first measurement to the second measurement, so from 2.4 to 3.8, we would need to add on 1.4 centimeters. Now, we don't know if that's the rule. We need to try it for the other ones. So the second one, well, to get from 3.8 to 5.2, we do need to add on 1.4 again. So we're probably onto something here. Let's try it again for the third one. 5.2 add 1.4 is 6.6. So that relationship holds for everything there. So we know that whatever the question is, it's going to be something to do with, well, it grows by 1.4 centimeters each day. So let's have a look at part A for this one. Ooh. If the seedling continues to grow at the same rate, how tall would it be 4 days later? Well, I'm going to guess that that's 4 days after it's grown, so as in 1 day after the third day. So measurement on the third day is 3.6, so if we add 1.4 to that, we would get 8.0 centimeters. How tall it would be after 5 days? Well, it's going to be the measurement on the fourth day, so 8 plus another 1.4, which would give us 9.4 centimeters. Now we've got to write a formula to actually make this a bit more official, I guess. Now, first thing that we've got to do is actually define the variables that we're using here. So I'm going to say D is going to be number of days, and H is going to be the height of the plant. It's going to keep it simple. All right, now in a very similar way to the number patterns questions before, we know that for every day that we add on, we're adding on 1.4 centimeters worth of height. So the height, or at least the rule for it, is going to be something to do with 1.4 times the number of days. Because for each extra day, you get another 1.4 centimeters. So there's that multiplicative relationship between them. What you've got to work out is what you've got to add on for it to make sense and for it to work. Now, what I'm going to show you now is just to consider the first measurement, because when it's 1 day later, the number of days equals 1. But when it's the first measurement, the number of days is equal to 0. And 0 times 1.4 is 0, but you'd have to then add on 2.4 to get the height. So I think it's going to be something to do with, let me see if it scrolls down for me. My computer's getting a bit slow at the moment. 1.4 plus, oh, it's gone too far. My brain's going slowly because I'm pretty sure I just said 2.4, but I've forgotten. Yeah, there we go, 2.4. Come on, computer. Plus 2.4. Now I'm going to test that by having a look at some of these other two. So using that rule, I'm just going to write it up on the side. H equals 1.4 times number of days plus 2.4. Let's test it for just to save a bit of time because I know it works. I'm just going to show you how it works for the 2 days later plant. So H is equal to 1.4 times the number of days, which is 2, plus 2.4. 1.4 times 2 is 2.8. 2.8 plus 2.8 plus 2.4 is 5.2. Awesome. So we've got a pretty good idea that that definitely works. Now the other two questions that we have on here are I'm not going to go into the last two. I'm just going to do one more. I'm going to do, let's say, like F. I'll pick at random. What's the height of the plant after 25 days? So the height is equal to 1.4d plus 2.4. So 1.4 times the number of days, which is 18. No, it's not. For F, it's 25. And then I'd add 2.4 onto that, and I'll let you guys work that out yourselves. I'm not going to go over G because it's actually more of a year 9 question because it uses the inverse of the formula. But if anyone's super keen and interested, I can show you that in class. Okay, I'm just going to scroll back to the top super quickly just to point out a couple of extra little snippets. And sorry, it's going all over the place. If you would prefer just to look over the well, not so much prefer because you've made it to the end of the video, but if you want to have a look at a paper copy or a PDF of the solutions there on Connect, your test is on Tuesday. That's the other important thing to remember. But Apart from that, if you've got any questions over the weekend, just add them to the discussion board or email me directly. That's totally fine. But for now, from the T-Rex and I, it's goodbye.